Hello student, my name is Anil. So today we are going to start our chapter Biomolecules. So biomolecules are complex which are the basic of the life. These are the complex which are the basic of life, of living life. Okay, living things. And they only not the basic of life, but they help in growth, maintenance and their ability to reproduce. So in biomolecules we have examples like carbohydrate, protein, enzymes, hormones, lipids, nucleic acid, etc. So in this chapter we will discuss about carbohydrates, protein, enzymes, hormones, lipid, nucleic acid, etc. So first we will take carbohydrate. So what are carbohydrates? Carbohydrates are optically active substance. They are optically active substance. They are the polyhydroxy aldehyde or polyhydroxy ketone. So we have classification of carbohydrates. Carbohydrates are also known as saccharides. They're known as saccharides between sugar. So on the basis of the hydrolysis, carbohydrates classified into different categories. The first class is monosaccharides, means which cannot further hydrolyze, which cannot be hydrolyzed, is known as monosaccharides. Then we have second one, that is known as oligosaccharides. Oligosaccharides are which those give 2 to 10 molecules of monosaccharide on hydrolysis. On hydrolysis, they give 2 to 10 monosaccharides. 2 to 10 molecule of monosaccharides. And in this we have, if they give 2 molecules of monosaccharides, they are known as disaccharides. If they give 3 molecules, then they are known as trisaccharides, 4 tetra, like this. And last we have the third one is the polysaccharides. Poly means if they give 100 to 3000 molecules on hydrolysis. If they hydrolysis and give 100 to 3000 molecules, then they are known as polysaccharides. So another classification of the carbohydrates is sugar and non-sugar. We know that sugar are soluble in water. They have sweet taste. They are crystalline. So those carbohydrates which have all these properties are known as sugar. And we have mono and oligosaccharides are example of sugar. And non-sugar, which are amorphous, tasteless, insoluble in water, are known as non-sugar. And polysaccharides are the example of non-sugar. Now next one is reducing and non-reducing sugar. Means those sugar which can reduce tolerance, reagent and failing solution, they are known as reducing sugar. And all the monosaccharides and disaccharides are the example of reducing sugar. Mono and disaccharides are the example of reducing sugar. Okay. Now, non-reducing sugar, which do not reduce tolerant reagent and failing solution, are known as non-reducing sugar. In this we have examples of polysaccharides. So next we are going to discuss monosaccharides here. And in monosaccharide we will discuss about the molecules which cannot be hydrolyzed. Molecules, it's already discussed, molecules which cannot be further hydrolysis, they are known as monosaccharides. Okay, these monosaccharides have 3 to 7 carbon atom. Now the monosaccharides are also divided into two categories. One is aldose and second is ketose. So those monosaccharides which have aldehyde group at C1 carbon, they are known as aldose, and which have ketone group at C2 carbon, they are known as ketose. So example of aldose is glucose and ketose is fructose. So now we are going to discuss about glucose and its structure. So glucose can be easily, glucose formula is C6H12O6, and it can easily prepare from the sucrose. Sucrose on hydrolysis give glucose and fructose. Sucrose formula is C12H22O11 and glucose formula is C6H12O6 and fructose is also C6H12O6. Now, structure of glucose. So we will first discuss the open chain structure. That is CHO, CHOH and CH2OH. Now you see there is one aldehyde group, one aldehydic group at C1 carbon, and they are 4 alcoholic group. Okay, but these alcoholic group are secondary alcoholic group, and there is one. There are four in number, 4 secondary alcoholic group, and there is one degree alcoholic group. Okay, this is the open chain structure of glucose. Now we will give some evidence in reference with the aldehydic group, alcoholic group present in the glucose. So first one, first evidence is the presence of aldehydic group. How we prove that the presence aldehyde group is present? So if this alcohol is reacted with hydrogen cyanide, we get CHOH, CN and CHOH and CH2OH. So we get glucose cyanohydrin. So this reaction suggests that glucose contain the aldehydic group, and aldehyde group have CO group, that means carbonyl group. So this is a proof. This reaction only takes place when there is a carbonyl group is present. So carbonyl group is present in aldehyde only, so they'll form glucose cyanohydrin. Now another proof we can give, glucose can be oxidized. Another, you can say glucose CHOH, CH2OH. On oxidation, in presence of bromine water, give COH, CHOH, CH2OH, gluconic acid. So this is another proof that aldehyde group is oxidized. Aldehyde group is oxidized to carboxylic acid, carboxylic group. So there are two reactions which show the presence of the aldehyde group in glucose. Next is the presence of Next we will give the presence of alcoholic group present in alcoholic group present in alcohol. So there are 5 alcoholic group, 4 secondary, 1 primary alcoholic group. So how we give proof to that? So glucose, when reacted with acetic anhydride, it undergo acylation. So we have CH3 twice acetic anhydride. So when it react with glucose react with acetic anhydride, we get acylation on the 5 carbons. OCO CH3 whole 4 and then CH2O CO CH3. So now you can see there are 1 and 4, 5 total alcoholic group present in glucose, and all the 5 group are replaced by our acyl group. So acylation. So this proved that there are 5 alcoholic group present in the glucose. Now the last reaction to show that primary alcohol is present as which site. So for primary alcoholic group, primary alcoholic group, so we have glucose CHOS 4 CH2OH. It react with nitric acid. It's an oxidizing agent, so oxidation will take place. So by this we get succinic acid. So this is the proof that primary alcohol group is present at the end of the carbon and at the end of the glucose, or alcoholic group is present at the end of the carbon chain. Now another one is how we can change this open chain structure of glucose in a straight chain. See, if glucose C6 H12O6 when react with HI in presence of red phosphorus, we get hexane CH3 CH2 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 and CH3 plus iodohexane CH3 CH ICH 2 CH2 CH3 and hexane and 2 iodohexane 2 iodohexane. So all these are the properties of open chain structure of glucose.